Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then I will start with the problem solving for today's session as well. Hi Rishit, okay. Hi to everyone else as well. Hi Mahendra Singh as well. Okay, so let me quickly share my screen and let's discuss this problem. And today's problem is quite easy, right? The problem that we are going to discuss, because it is based on a particular prerequisite or a prerequisite kind of strategy problem. Okay, so let me quickly search this thing, that is GFGPOD, and then let's get back to that problem. Okay, so yeah, just a second. Now this was the problem, that is nearest smallest tower. So let me just remove the code from here. Right, now in this particular problem, what like basically, if you will see nearest is smaller, right? When you see these words, right, nearest is smaller, right? So the problem name, if you will see, so the problem name is nothing but nearest smaller tower, right? Smaller tower. So in this case, when you see these two words, right, when you see this much part, which what idea comes to your mind, which data structure or anything comes to your mind, right? Can I say that the thing that comes to my mind is nothing but next smaller element on the left, okay, next smaller element on the right, okay, next smaller element on the right, next greater element on the left, next greater element on the right, correct? So these concepts come to my mind, and when this comes to my mind, then basically stack data structure comes to my mind for solving this problem. Is that clear to everyone till now? Right. If you have heard about this, next is smaller element, next is smaller to the left, right, all those things, then these things should come to your mind. Is this much part clear? That is the prerequisite, that you should already know how to find the next is smaller on the left, next smaller on the right. Is this much part clear? Please write yes +1 and give me a like on the video if this much part is clear, right? Is this, can I expect that you know this much part, right? Next polar element on the left, next polar element of the right. Okay, Rishit says that he is clear with this. All right, I hope that others are also. If you don't know those questions, then these problems exist as questions themselves on Geeks for Geeks. You can try them out, because without knowing these problems, solving this problem can be difficult. If you know these problems, then this problem is just a subset. So that is why this problem becomes easy if you know the stack approach for solving the next smaller on the left and next smaller on the right. Okay, now what the problem says, the problem says that for like you have been given an array, for each element you have been given ARR of I, so which represents the height of the tower, right? So every ith element is representing what, every ith element ARR of I, okay, it is going to represent what, it is going to represent the height of the tower, right? It is going to represent the height of the ith tower. Now it says that for each tower, find the nearest possible tower that is shorter than it. You can look in the left side and right side. Okay, so what you have to do is, for every array of I, it says that for each tower find the nearest smaller. Okay, so for this guy you have to find the next smaller element, next smaller height on the left side, and you have to find the next smaller element on the right side. Okay, so that is why this is a prerequisite, and this we will do using the stack approach, right? So we can have a left array name and we can have a stack one, which can help us to find the next smaller element on the left. And similarly, what we can do is we can have a stack, let's say st2, and that will help us to find the next smaller element on the right for the ith element, right? That is how we can do it. Is this much part clear? Because this is the first thing that the problem says, that for every ith element, what you have to try to do is, you have to try to look for the next smaller element on the left, okay, and then index of the next smaller element on the right. So for that, we will have a left array and the right array. Okay, we can have a stack 1, stack 2, and we can, for the left side we can use the next small element on the left concept, and for the right side we can use the next small element on the right concept. Okay, this is monotonic stack concept. Yes, you can say that it is a monotonic stack concept. Yes, Rishit. Okay, so is this much part clear, that this is a prerequisite that you should already know in order to execute this line, that is, for each ith element find the nearest on the left side and find the nearest on the right side. You need to know this particular technique, that is nothing but next small element on the right and the next small element on the left. Okay, so once that is done, okay, suppose that once you have the indexes, right? So once you have stored the index of the next small element for every ith element on the left side, so we have a array for that. Okay, let's say we have a array named as left array. Okay, and we have a array named as right array for us, that is for the right part. Okay, then it says that if two smaller towers are at the same distance, then we pick the smaller tower. Okay, so basically if let's say like I will tell you further, आज वाला पोस्ट करना भाई, ये तो बच्चा भी कर लेगा. Actually, Nihal, the problem for today's like problem of the day for today will be solved tomorrow. Okay, so we will not be solving it today. That will be solved tomorrow. Okay, so what we can do is, first of all, we can try to find the next smaller element on the left and the right. Okay, so let me just quickly try and implement that approach. Okay, so I will declare two stacks, obviously. So stack. Okay, int, and let's name it as st1 comma st2. Now after that, what we will do is, we will also have the like size as n. So let's say int n is equal to arr dot size. So let me take the size as well. Now after that, what I'll be doing further is, I'll take two arrays that will store the left indexes and the right indexes. Okay, so I will have vector int, let's say arr, sorry, vector int, let's say left. Okay, and that will be of size n only, right? Because it will store the index of the nearest smaller element on the left, and right will store the index of the nearest smaller element on the right. So I'll declare a right array as well. So let me declare it like this. So it will store the index of the next smaller element on the right side. Okay, now once that is done, so what I will do for it is, I will iterate, like I will first of all try to find the next smaller on the left. Okay, so what I will do here is, next smaller, if I'm finding the next smaller on the left side, so I'll say that, okay, for int I starts from 0, I is lesser than the size of the array, and I will do I plus plus. So I'll start iterating, and what I will say is that, if the stack one dot size, okay, basically stack one will store for the left element, if it is greater than 0. Okay, if the stack one is not empty, and it happens that the stack like it happens like in the stack I'll be storing the indexes. So if it happens that the current top index that is stored in my stack, so let me write this part as st dot top. If the current top index that is stored at the top of the stack, okay, if it is greater than equal to array of I, right? So I have to find the smaller ones. So that is why for the larger ones I will pop this out, because if this particular top index that is there, if it is having if at this index I'm having a height which is greater than the ith height, so I don't want this height, so I will remove this. Okay, and then I will simply say that if after coming out of the loop there can be two reasons, either the size becomes empty, or it might happen that I have found that index. Okay, so if the size of the stack is greater than 0, then I can simply say that my left for this current ith index, the next smaller on the left will be nothing but the st dot top, the top index present at the top of the stack. That will be the case. Otherwise, if my stack is let's say if my stack is empty, in that case I will not have anything, so I'll mark my left of I as -1, indicating that there is no next small element on the left side for this ith element. So is this much part clear to everyone, guys? Please write yes in the chat. Guys, is this much part clear to all of you? Please tell me. Okay, please write clear in the chat if you are clear with this thing. And after this, what we will do here is, we will simply have another loop. So let me write it somewhere here. So now we will try to find the next smaller element on the right side. Okay, so what we will do is, for this we can simply start int I starts from nothing but n minus 1 because I am finding it on the right side. I is greater equal to 0, then I will do I minus minus simply, right? And then what I will do is I'll again, like, similar loop will be used, but the stack will be different. So I'll say that if the stack 2 size, okay, if it is greater than 0, and this particular thing happens uh, that the element at the top of the stack, so let me do one thing. Let me first of all make it as sp1, otherwise I'll get some errors later on, and let's make this as st1 also, right? Then I will check that if the current top index at, and if the index at the current top of the stack, if it is greater equal to the ith guy, right? So in that case I need to pop it out. So what I will simply say is I'll say that, okay, let's pop it out, right? And when I'll come out of the loop, so that there will be two reasons: either the stack is empty, or it might happen that I might have found the element. Okay, so if the stack size is greater than 0, then what I will do is I'll say that right of I is equal to nothing but st dot top, st2 dot top. Okay, that is what I will do. And otherwise what I will do here is I will say that right of I is equal to -1. Right, that is what we are going to do. Is this much part clear to everyone, guys? Please write yes in the chat. Okay, Rishit says yes, he's clear. What about other people who are clear? If you are clear with this much thing, then please write clear in the chat, guys. And also one more thing, you can make sure to hit the like button as well. Okay, if you are clear till this much point, then you can, guys, do one thing. You can hit the like button and give me a +1 or a yes in the chat if you are clear till now, right? Then only the execution part is left. Once I have found the index of the next smaller element on the left side and the right side, then only I need to execute the further part. Hi, Naikaj. Okay, so Naikaj has come there after a long time. So very good evening to Naikaj as well. He has also been a regular viewer for us. Okay, thanks a lot, Aman. Thanks a lot, Rishit. Nihal, आज वाला करना भाई, so आज वाला कल होगा, right? Same दिन same question नहीं होता है. Okay, now after this let's move forward and see what the problem says further. It says that if two towers, like, see what is the distance, right? If there is a particular ith guy, right? If there is a particular ith guy, so for it the left has been stored as left of I, right? The next smaller element on the left has been stored as left of I. For the ith guy, the next smaller element on the right has been stored as right of I. Okay, so the distances will be what? Distances will be nothing but absolute of I minus left of I, right? For the ith guy, the distance of it from this particular tower will be nothing but I minus left of I, and for the right guy, that will be nothing but absolute of I minus right of I, right? So whichever they are saying, that whichever distance is smaller, that you have to choose. Otherwise, if the distances are same, then you have to choose according to the smaller height and all those stuff, right? So that is what we need to implement here. So let's see if I've declared any answer array or not. I think that I have not declared it. So let me declare another answer array and let's name it as size with n, right? Now that's the last thing that needs to be executed is just whatever they are saying, right? They are saying that let me tell you what they are saying. They are saying that let me do this. I start from 0, I is less than n, then I will do an I plus plus, right? And now what I will do here is I will simply first of all check. Okay, let us say that if I left of I is equal to -1, so and the right of I is also equal to -1, right? Right of I is also equal to -1. So this will indicate that neither on the left side for the ith in element, for the ith tower, there is no next small element on the left side or the right side. So in that case, I should do what? In that case, I should simply update my answer of I as -1 because it is not available, right? Otherwise, what I will check is, otherwise, let's say if only the left of I is equal to -1, right? So in that case, if the left of I is only -1, then the nearest tower will be only one, that is on the right side, and that will be stored in right of I. That will be the index. Okay, so that I will store. Otherwise, if I come to the else if part, and let's say if it happens that the right of I it's equal to this thing, what should I say? If the right of I is equal to -1, right? So if it's equal to -1, so in that case I can say that the next smaller element on the right is not available, but the next smaller element on the left is available because left is not -1. So I'll update it to left of I. Okay. Otherwise, they are saying that if this dispute is let's say if the left, if there was no next smaller on the left, like, see, First thing is that if there is no next smaller element on the left or the right, then answer will be -1. If there is a next smaller element on the right side but not on the left side, so I'll update with the right side. If there is the next smaller element on the left but not on the right, so I'll update with the left. Okay, otherwise what I have to do is I have to make the decision based on the distances. Okay, so if the absolute of I minus left of I, that will be the distance between the ith guy and the left guy. Okay, if it is lesser than, suppose if it is lesser than I minus right of I, so if the nearest tower, if the nearest tower for the ith tower, if the nearest smaller tower on the left side is having lesser distance compared, because distance is always absolute, so if the nearest tower for the ith tower on the left side, if it is having lesser distance compared to the right tower, in that case what I will do is I'll say that okay, answer of I is equal to left of I, because that is at a that is much more closer to us, right? That is the thing. Otherwise what we will do is, else if suppose the opposite happens, right? If it happens that absolute of I minus left of I, right? If this distance suppose is greater than absolute distance between I minus right of I, so if the absolute distance bit of the like if the distance of the ith tower is greater for the left closer tower and it is lesser for the right closer tower, so I'll update the answer as right of I. So I'll say that okay, answer of I is equal to right of I. That is what I'm going to do. And once this is done, so in that case I'll come to the like else if part, right? Now if suppose that the distances are same, then in that case I'll store the smaller tower. Please write smaller in the chat, guys. Okay, if suppose that the distances are same, so in this case also in your code we have not pushed any value. Okay, yes, sorry. So I have not pushed any value, that is one mistake. So after everything, after every index I should always push ith st1 dot push I and st2 dot push I. Sorry, I just forgot in the flow. Okay, so yeah, I should always push the indexes. So thanks a lot, Rishit, for correcting me. Okay, now suppose if the distances were if the distances dispute has been resolved and the distances are same, then whichever is smaller, that I will store. Okay, so thanks a lot, Rishit, for clearing it. Right now what I will do is, if thanks a lot, Shay, as well. So if the guy on the left side, okay, now I will check that if the guy on the left side is lesser than or equal to, let's say, the guy on the right side. So if the guy on the left side is smaller, then I will say that okay, answer of I is equal to left of I. That is what I can simply say. Otherwise I can say that okay, if the right guy is greater, like if the right guy is having lesser distance, sorry, lesser height, then in that case I'll store it. So I'll come to the else part and I'll say that okay, answer of I is equal to right of I. That is what I think we can do. And after this loop is over, then we can simply return the answer as well, right? The answer error that we have stored. So this part is pretty simple, right? And it's very logical as well. We simply check if there is a next, if there is no next smaller on the left or the right, so we mark it as -1. If the left if there is no next nearest smaller element on the left, then we update with the right one. If there is a no nearest element on the right side, then we update with the nearest on the left. Otherwise we update on the basis of the distance, whichever has the lesser distance. Even if the distances are same, then we have to consider the height. So whichever has the lesser height, if the left has the lesser equal to height, then I'll update with the left. Otherwise I'll update with the right, and simply I'll return the answer. That is what the question says actually, right? Now let's try and compile this code to see if it can get accepted or not. Is this much part clear to everyone, guys? I hope this much part is clear. I have written somewhere st.pop. Where have I written this thing? Okay, st1.pop should be here, right? Okay. So is this much part clear to everyone? Please hit the like button and give me a +1, guys. Okay. It says that ARR of left and ARR of right. Did I make any mistakes here? Not sure. Okay. ARR of left of I should have written. No? Where am I doing this mistake? Mm, in which line I'm making this mistake? Line number 33, I think, right? Where am I making this mistake, guys? Can you tell me? Mm, let me just check with this part. If this is relatable to this. Okay, error of left and error of right. Where have I made this mistake? Yeah. So yeah, if this thing, I should write as right of this is okay. If the value, so this was the mistake. Line number 84. Yes. Now it works on the samples. Let's try and submit it to get it accepted. Okay, so it was a basic mistake. I should have written left of I instead of arrow of left. Yeah, so it does get accepted. So is this problem clear to everyone? If you are clear with this problem, then please make sure to hit the like button and give me a +1 in the comment section, guys. Right, talking about the time complexity for my code. So since I'm using a linear approach, so overall time complexity is still order of n, and the space complexity of this approach is nothing but order of n as well. And the company that has asked this particular question is nothing but Atlassian. Okay, so a very high paying company. So the company that has asked this particular question previously is nothing but Atlassian, right? So you can give a +1 for that as well. Now let me provide you the code for this particular problem. Okay, and same code approach will be used in other languages also, so don't worry on that part. Let me open the FDID. ACOP Rishit is writing. What about others? Others are also pretty much clear with it or not? I hope that others are also clear. Okay, let's try and run this code and see if it gets like it's get compiled or not. Okay, so it does work. Now I will provide you a solution link. Okay. I'll just provide you with this. So this is how we do this problem using the stack approach. Okay, other people are also clear. I hope that others are also pretty much clear with this particular problem, right? Because it was quite easy problem, just based on the next greater element, next smaller element. So if you know how to find the next greater element, next smaller element, then finding the final answer was just a case of if else statement. So it was not that difficult. I hope that you understood this problem. If you did, then please give me a +1 before I end this session. Okay, please give me a +1 and write understood in the chat. Tomorrow also I'll be discussing the problem, that is today's POD. I'll be discussing tomorrow at 6. So make sure to attend the session tomorrow. Okay, so yeah, thanks a lot for joining everyone, and I will see you with another problem of the day tomorrow. Till then, keep coding, guys, and good night. Thank you for joining this particular session. Thanks a lot, Rishit, and thanks a lot, Naikaj, as always, and thanks a lot, Shreya, as always. Okay, thank you, everyone.